The question is, suppose a firm has following production function, that is f of x1, x2, x3, x4 is equal to minimum of x1 comma x2 plus minimum of x3 comma x4. Okay, the per unit cost of input xi is being given as wi, where I is equal to 1 2 3 4. Suppose that input price of good x1 is being given as 1, that is w1 is equal to 1. Input price of good x2 is 5. Input price of good x3 is 3. This w denotes the input input price or input cost, and w4 denotes the input cost of this x4. If the firm is minimizing cost, okay, so the firm is trying to minimize the cost, which of the following input choices by the firm can be observed? We are being given the four options. We need to find out which of these input combinations will the firm choose to minimize its cost. Okay, so what we are being given? We are being given a function that is f of x1 comma x2 comma x3 comma x4 is equal to minimum of x1 comma x2 plus minimum of x3 comma x4. Okay, this first term, okay, here x1 and x2 are the perfect complements of each other. This is the min function. Also x3 and x4 are the perfect complements of each other. But this production function jointly is a perfect substitute production function. Okay, so we have one perfect complement here. Again, here we have another perfect complement, goods. These two are the perfect complements of each other. These two goods are perfect complements of each other, but together they jointly represent a perfect substitute production function. Okay, so this function and this function are perfect substitutes of each other. I will also at the end of this video explain it with an example. Now also we are being told the input price or input cost of good x1 is being given us as 1. Input cost of good x2 is being given us as 5. Input cost of good x3 is being given us as 3, and input cost of good x4 is being given us as 6 here. Okay, our goal is to minimize cost. Okay, minimize cost. As I told you, this production function is some kind of hybrid production function. Okay, we have the two perfect complementary goods first, and jointly they represent the perfect substitute goods here. Okay, if we want to minimize cost, let me rewrite this production function. Let us say f of, we have x1 x2. I will not write it here, it will occupy space and time here. So in this place, minimum of x1 x2, let us denote it by capital X. Then we have plus, let us denote it by capital Y. Okay, now this production function reduces to a perfectly perfect substitute production function. Okay, now what is the cost of producing this x? Let us denote it by px. Okay, what will be the cost of producing x? So x denotes this production function x1 and x2, so which will be equal to w1 plus w2. That means px will be equal to w1 plus w2 is 1 plus 5, which comes out to be 6. Okay, and what is the cost of producing y? So let us denote it by py is equal to, so x3 and x4 are here. The cost is w3 plus w4, so py will be equal to 3 plus 6, 3 plus 6, so py comes out to be 9. Since firm is trying to minimize cost, okay, and we have this perfect substitute function. So we need to find out which of these two choices the firm will make to minimize its cost. Here we have seen price of x is price of this comes out to be only 6, and price of this good y comes out to be 9. Okay, here we can see it costs less, you know, producing x means producing this costs less than producing y. Y denotes the second function py. Okay, when this is the thing given this production function and price of x is less than price of y, obviously firm will try to choose to produce that very combination which has least cost comes out to be for x. That means firm will choose to produce x. Okay, so produce x, and x denotes x1 and x3. Okay, so x denotes our minimum of x1 and x2, sorry. Okay, so firm will choose to produce this very thing, this very stuff. I have told you it is a kind of a hybrid production function where we have two perfect complement goods, plus we have the perfect substitute combination here. Okay, so firm will produce x, and in x we have x1 and x2. That means firm will choose to produce the positive quantity of x1 and positive quantity of x2, and will produce zero quantity of x3 and zero quantity of x4. Let me write here, there is lack of space. So firm will obviously choose to produce this the first part of this. So that means it will produce positive quantity of x1, positive quantity of x2, zero quantity of x3, and zero quantity of x4. Okay, so the correct option should be we have greater than, equal to, greater than, equal to. So this option should be correct. Combination B should be the answer. That means combination B can be the solution here. Now let's give some intuition. I don't know whether the example will go perfectly well, but just trying to make it more relevant here. Okay, so let us denote we have f of x1, x2, x3, x4. Okay, so you can think of this as, let us say we have minimum of x1 and x2. Okay, what does this mean? Let me say that we want to produce, let us say we have two goods here, two products, whatever you say. Let us say we have Pepsi and coffee. Okay, let us say we want to produce the cap of Pepsi bottle and the bottle itself. Okay, so this will denote the min function. Plus we have minimum of x3 comma x4, and let us say this this function denotes that we are trying to produce a bottle and a cap of Coca-Cola. Let us say this is the cap and this is the bottle. Okay, here the Pepsi, which is being denoted by black, and Coca-Cola with red, uh, cap and bottle of Pepsi are perfect complements of each other. That means for every bottle we need one cap, and similarly For Coca-Cola, for every bottle we exactly need one cap here. Okay, but together these two are the perfect complements of each other. So this denotes, let us say this denotes the Pepsi. Okay, let's use the color here, Pepsi, and this denotes the Coke, COKE. Okay, so producing one cap and one container. So minimum function means that these are the perfect complements of each other. Coke, to producing one Coke bottle, we require one cap and one bottle. These two, X3 and X4, are the perfect complements of each other. But these two are in its, in itself, what we call the perfect substitutes of each other. Okay, so I'm just trying to give this example. I know it is, a rude kind of, or a raw example. I don't know whether it will work or not. We are being told that x1, that means a cap of Pepsi costs us. Okay, let me, a cap of Pepsi, the input price is being given by W1, which is one, input price of, and to produce the Coke bottle, that means the input price of Pepsi bottle is 5. Okay, similarly, to produce one cap of a Coke bottle, the input price is 3, and to produce the bottle without cap, the price is, input price is 6. Okay, we also want to minimize cost. Minimize cost. Okay, so to produce one Pepsi bottle, total cost comes out to be 1 plus 5, which comes out to be 6. To produce one Coke bottle, the cost comes out to be 3 plus 6, which comes out to be 9. Obviously, 6 is less than 9. The firm will choose to, you know, produce Pepsi bottles only. That means firm will choose x1 and x2, the positive quantities of x1 and x2, and zero quantities of x3 and x4. Okay, so I was just trying to make it sense what exactly is meant by this hybrid production function. We have the perfect complementars. These two are the perfect complementars, these two are the perfect complementars, but together they form a perfect substitute production function. Okay, so price of Coke is, input price of Coke is only 6. Okay, let me write it here, or sorry, price of Pepsi, price of Pepsi, producing Pepsi is less than price of producing Coke. Obviously firm will choose to produce only this very thing, that means Pepsi bottles, and this simply means we will produce a positive quantity of x1, positive quantity of x2, zero quantity of x3, and zero quantity of x4. I hope मैं तो गया explain करूँ. Thank you.